In this video, we can discuss what is a structure, data structure called an index. Okay. So index means it is indexing is a data structure, which is a technique used to efficiently retrieve the records from a database files, and we can access the records based upon some of the attributes. Okay, and these with the help of these attributes, we are doing the indexing. The indexing on a database table will be providing a convenient mechanism for locating a particular row or a record without scanning the entire table. Okay, and thus we are greatly reducing the time that a query takes to process. So indexing is actually specified on one field of a file. So here, one form of a format for having a index file is that field entries should be in the form of field value, that is an attribute value. Okay, that in which a table is having a field value or an attribute value and a pointer that points to that particular record. So which is ordered by a field value. It is not necessary to that the field value to be ordered. Then if there are some indexing that where ordering is also not done. So the index files occupies considerably less disk blocks than a data file because their entries are much smaller. Now we can see some of the advantage and disadvantage of using indexing. It stores and organizes data into the data computer files, and it makes us to access. The main advantage is we can find a data and we can access the data at a very small amount of the given time. And it is a data structure that is added to a file in order to give a faster access to the data. And again, it reduces the number of blocks that a database management system has to check. So the number of blocks that it has to be means checked for a particular, when you are giving a query, the number of blocks that it has to search, that will also be reduced when indexing is done. So index needs to be updated periodically. So the disadvantage is that if you are inserting or deleting a record from the table, main table, then the index structure has to be updated. So whenever there is an insertion or deletion in the record in the main table, then we have to update it. So that takes little time and there is some expense also in updation. So next we can see what is a structure of a single column and concatenated indexing. So here the single column index table or a multi-column index table is given. So here let's take an example of a multi-column, that is a multiple column index table. So here we have an original table here with the location numbers 1, 2, 3. It is serially it is indexed. Okay, and we have the year, that is 2016 and 17. And the next field is make, that is a company name and the model. Okay, so in the we can have the index. The index is done on the main index is done on the attribute field value year. Okay, so here I have done the main ID 1, 2, 3, 4, 5, and the year is again 2016. First and second is 2016, and last one is 2017, right? And we have a pointer for each record. So here, this is a pointer which will be pointing to the record, that is pointing to the Toyota, that is make value. Again, the second one is again pointing to the Honda record. Third is again, this is also good. So there is a pointer that will be pointing corresponding to the data field. Okay, so here we uses the primary key. So here the primary key, we can use the primary key also to, here we have the value created is not a primary key because here it will be having multiple values, right? So here it is possible to create indexing on a primary key also. So in order to create multiple index, such as indexing based on the year, or we can group some of the field and do the indexing is also possible. So this is a multi-table indexing and which will help to get a specific query results faster. Now we can see um, the different types of index. So the index can be broadly classified, categorized as a dense index and a sparse index. The dense index means it has a index entry for every search key value. If the search key value is a primary key or any other keys. Okay, that is a attribute value. Search key means it is the attribute value. Okay, so here the index entry will be having every value entry for every search key value. Okay, and again, what about the sparse? Sparse means it is a non-dense, and it will be having only index entries will be having for some of the search values, whereas in in dense thing, index entry is for every search value. So we can, so here this is the representation of the different types of index. So again, the types of index can be classified as three different types: primary index, clustering index, and a secondary index. The primary, again, we can broadly classify into the dense as well as the sparse index. So given this is the structure of the index, the structure as it is actually the index means it is a data structure. It is a small table having two columns. Okay, two columns, and the first field is a search key, which belongs to the main table. Okay, so this is actually that entry in the main table. That is a field value. And the second thing is the data reference, that is a pointer. So the first column will be the any key value, which can be a primary key or a candidate key of the master table, main table. And the second thing is the pointers that will be holding some of the address value. Pointers means that you hold the address, right? So pointers that is holding to the address of the disk block where this particular key value is found. Okay, and the index are sorted, and therefore we can say it is a ordered indexes. If the index are sorted, if the key values, if this file is sorted based upon the key values or the search key values or field values, then we can say it is a ordered indices. Okay. This is an example for dense index. In dense index, what is that? It is actually every record of the main table. The index table, this is the index table and this is the main table. Okay, so index table will be having search values. So for every search values of the main table, there will be having a index table entry. So here, this is the main table, and here this is the field value is UP, USA, Nepal, and UK, right? For every entries, there will be a index values also. Here in this table also, there will be a entry for every entry in the main table. Okay, and the second field is a pointer. So the pointer will be pointing from this to the address to this location. Okay, the primary indexing, it is like actually a primary indexing, but contains a record for every search key. Okay, so here, so once again, then dense means it will be having uh, pointer value. So it will be having the entries, the index file entries, field value will be there will be values will be there for every fields in the master table. And what about the sparse indexing? Sparse indexing means it consumes less spaces than the index spaces, and also it is a bit slower than the dense one. It does not include the search key for every record. Okay, so it will be storing a search key that points to a block. So here, this is a given index here. This is the data file A, B, C, D, E, F, G, H, I. Here, this is the data record. Okay, so index record. So from A and B, there will be a pointer from the record from this thing to the file. Okay, so the sparse index, again C and D will be, there will be a pointer towards the record file or a block. C and D together, there will be a single pointer. Okay, for an E and F together, there will be a pointer towards the data file. So next one is the first type of indexing, that is a primary indexing. In primary indexing is based upon the ordered data file. Okay, so the based upon, actually it is based upon the ordered And the key value, mainly it will be generally a primary key of the table. Okay, it will be done on an order data, as well as the field value will be the primary keys. Therefore, the name primary indexing. Okay, as the index is composed of this primary key, the constraint for the primary key is that they are unique, right? So every field value will be having a unique value, and it will not be having any null value also. Okay, and and it will be having a one-to-one relationship with the data blocks. Okay, so here this is a primary index, and it is a sparse index, and therefore it includes the entry for each block. So this is a block 1, and this is block 2. From 4 to 55, block 2, 5 to 3, it is block 1. Okay, so you will be having a, and this is the index field. Okay, this is the data file, and we are taking this attribute as the index field value, search field value for the index file. So here I am taking one data. Here I am taking 5 from this block, and again this from this block I am taking 4, and there will be a pointer. So here the second thing, this is the index here. There will be a pointer pointing to the block 1, as well as from here the pointer will be pointing to the block 2. Okay, so this is how the primary indexing are done. I hope it is clear. Okay, so the main what are the main features of primary indexing? Here the search keys, the given search, this is the search keys, are right? So the search keys will be unique because it is a primary key, and the search keys may be in a sorted order inside a block. Okay, the search keys will be can be in a sorted order, and the search key cannot be a null value because it is a primary key. It cannot be a null, and it points to a block of data. It is also a fast and efficient way of accessing data from a data file. Okay. So next we can see here, this is the actual representation of this indexing, that is a primary indexing. So here this is the index file. Okay, so here primary key value is this thing, the name, the first name and the last name together. We are giving a primary indexing, and there is a block pointer. So this is the block, and every here this pointer is pointing to each and every block. Okay, so we can access the or if we want to search for a particular record, then the indexing from this pointer we can go to that particular block. Okay. Next type of indexing is a clustering indexing. So clustering means grouping some of the related records. The word clustering is a cluster meaning is grouping. Okay, so grouping some of the related records. That is what a clustering means. When there are related records are found. So if you are given a multiple related records, then we can use this clustered index. And it is also defined on a ordered data. Okay, ordered data. So the index table of the clustered indexing is created with the help of non-key values, which may or may not be a unique value. So clustering index means it is not necessary to have the primary key or a candidate key. It can be, the indexing can be created for a non-key values. Okay, so that is the field value it can have a repeated values or multiple values. Okay, so in order to achieve the fast retrieval, we group these columns having similar properties, and the indexing are created based upon these groups. And this process is known as clustering index. Okay. So here, as we can see in this diagram, so this is the our index file record, and this is the data file. So here, this is the index file record here. This is the field, and this is the pointer field. Okay, And here from this field, and this is the block. Okay, so here the pointer is pointing to the record. Hmm? Here also for the field number, here this is 2 again. This 2, the field value 2 is again, it is stored in this block number 1. So again, it will be pointing to the same block. So the pointer will be pointing to the particular block. Okay. So again, 2 and 3 is in the block 2, 3 as well as 4 is in the block 2. Therefore, the pointers to from block 3 and block 4 will be pointing to this thing. Okay. So for 2, it will be pointing to block 1. So this is how we are doing the clustering index. And the major characteristics of the clustering index is that we can do the indexing on a non-key values. That is most important. And the cluster, this indexing has to be, search keys are sorted. Okay, and the search keys always, it cannot be having a null value, and it is not necessary to have a unique value. It should not be a null value, and it is not necessary to have a unique. That is, it is not necessary to have a primary key or a candidate key value, and it requires extra time or to create this indexing. Okay, so next about this is a cluster example, clustering index on a department number. So here the department number is given as the field value for the record. So department number means many people will be having the same department, right? So here these are the department numbers 1, 2, 3, 4, etc. 4, 5, 7, and 8. And this is the data file, and this is a block 1, block 2, block 3, block 4, block 5, and block 6, and each block will be having different records. Okay, so here the size of the each block can accommodate up to 4 records. Okay, so here this thing, the block pointer from this field is pointing to this block, and again the block pointer of 2, the field value 2 will be also pointing to the same block, because this block contains both department number 1 and as well as 2. Okay. Next, about the secondary indexing. So till now we have discussed about the single level indexing. Now we can go to the secondary indexing. So here this is actually a 2-level indexing technique, two level, okay, and which is used to reduce the mapping size of this primary index. So means accessing a file for which some primary access already exists. Okay, the secondary index may be on a field which is a candidate key and can have a unique value in every record, or it can also have a non-key value with duplicate values. The index is an ordered file with 2 files. The first field means it will be having 2 files. The first field of the same data as some non-ordering field of the data file, that is the indexing field. The second field is either a block pointer, or it can point to another or a record pointer. It can point to a block pointer, or again it will be pointing to another record. There can be many secondary indexes for the same file. It also includes one entry for each record file. That is, it can have a dense index. So here this is the example. That is, here there are 2 level of indexing is done. That is, secondary indexing means 2 level indexing is done. The secondary index is also known as non-clustered indexing. Okay, so here in this case we can see that the dense index are there. Okay, so here the first level is this thing from 10 to 50. Again, another indexing can be done here also. So here, if there is another record, we can add these entries here also. Since we have, this is a pointer that is pointing to a record. Okay, so this one is a record. And again, this is another indexing record. And here, this is a pointer to the data file. Okay, so here we have a 2-level indexing is done. So from 10, it will be pointing to the record 10. 20, it will be pointing to 20. So this is actually a dense index. That is, it will be having entries. The data entries here in this file will be equal to the number of records in this data file. Okay. So again, this is actually a very big data file. That is the dense secondary level indexing with a block pointer and a non-ordering key field value of this file. Okay. So it's a larger version of the previous one. Okay. This is the first level done. And this thing is the data file. Here, the values, field values 1 to 8, again 9 to 16, 7 to 18. 18. Each field will be pointing to a data record. Okay. These are the properties of different types of indexing. That is, we have primary indexing, clustering indexing, secondary as well as secondary for key attributes as well as for non-key attributes. Okay. So number of blocks in the data file for primary indexing, the dense, it will be a down dense. Again, blocking, block on anchoring on the data file is this, it can be done. These are the different properties. Again, about the single level as well as the multi-level indexing. So because a single level means it is a ordered file, we can create the primary index to this index itself. So in this case, the original index file is called the first level index. And if we want to do the second level, then the indexing has to be done in second, a different index. Okay. So we can repeat the process to the third, fourth, etc. up to n levels. So that is why the name is, it is a multi-level indexing is done. Okay. The top until all the entries of the top level fit in one disk block. Okay. So the multi-level indexing can be created for any type of first level indexing as well as the first level indexing consisting of more than one disk block. So this is an example for multi-level indexing. So this is the outer block. Again, this is the there will be pointer and this pointer will be pointing to the inner block. Again, if you have another layer also, that can also be created here. And finally, you will be having the data blocks. Okay. Multi-level indexing. So the index table is stored in the main table. The single level indexing for they will be having a huge amount of data will be required. Therefore, we are going for a multi-level in order to reduce the space. Okay, introduced, we can divide the main data block into smaller units. Okay, and therefore the number of disk that is required to access also will come to a very less number. So this is an example for secondary indexing again, different block of pointers, and which will be pointing to the data file. Okay, so here the indexing is done based upon the department numbers. So here this is a block. This is a two-level indexing. So here, this is the first level and this is the second level indexing. And here also the field attribute. This is the primary key. Primary key is the field value attribute. So here, this is also a dense index. Okay. So that is all about for today's class. So there are some problems related to these indexing that we can discuss in class, next class. Thank you.